All right, welcome back to your bonus lesson for week number 7, getting us caught up from our day that we were gone for the cold. So here we go. Think about it. Would you rather have to fart loudly every minute or burp loudly every minute? Are you going to be a farter or a burper? A reminder that exam fixes are due this coming Wednesday, and that is also a work deadline for the for anything from Unit 7 and 8, except for the exam fixes, of course. All right. You did have to do problem set 9A for me last night. Again, that probably should have been fairly easy, but if you have any questions about those, send those my way. All right, so today we're going to be talking about rates of reaction. So I asked you to finish the POGL. Again, if you had any questions from the POGL, please send those questions my way. I also asked you to go ahead and take a look at the notes about reaction rates. Any questions on those, also send those my way. All right, so a couple left sides for you here. First one, it says the nitrate ion reacts with ozone in an aqueous solution, producing nitrate ion and oxygen. The following data were collected for this reaction at 298 K. Calculate the average reaction rate between 0 microseconds and 100 microseconds, and between 200 microseconds and 300 microseconds. Go ahead and do those, and then come back here once you're ready to look at the answers. All right, so the average reaction rate is going to be the change in concentration of the chemical divided by the change in time. And so for between 100 and 0 milliseconds, I'm going to go ahead and look at what is my delta concentration of O3 and what is the time. Okay, so the time obviously from 0 to 100 microseconds would be 100 microseconds. And then in terms of change in the concentration, I need to go ahead and subtract, which would be the higher from the lower, which is 1.13 times 10 to the negative second minus 9.93 times 10 to the negative third. Sorry, that's a little messy. That would give me 0.00137 divided by 100.0 microseconds, okay? And that would be, that's molar per microsecond. So then I divide that by 100, and I would get 1.37 times 10 to the negative fifth molarity per microsecond is the rate of that reaction. Likewise for the other, I would go ahead and subtract those out and divide by 100 again. And if I do that calculation, I get 5.5 times 10 to the negative sixth molarity per microsecond. All right, other left side, nitrous oxide decomposes to nitrogen and oxygen in the following reaction. Based on the reaction equation, which curve represents N2O and which represents O2? Okay, take a moment, check this out, and then come back here when you're ready. All right, so some things to note here. So N2O is a reactant, so we would expect that one to be going down, and that's the only one that we see. We only see one of those going down, so this one right here is going to be my N2O, okay? On the other part here, we've got O2, okay? O2 is a product, so it's going to be increasing over time, so it could be the blue or the red one, and we notice in terms of the coefficients, 2 times as much N2 is produced for every amount of O2, so we would expect the O2 to be produced less over time, so that means that the red one here is going to be the O2, which of course makes this one the N2. All right, so a couple things for you to do here. First of all, I've sent home the POGL rate of reaction assessment. If you can complete that and bring that back on Monday. And that leaves us with the following assignments for this. So again, the assessment that I just gave you, making sure you do summary and questions for the notes from reaction rate. Do the problem set 9B, and then you can watch the rate law notes for me, and then fix-its for Unit 8. Those are not due on Monday. Those are due Wednesday. All right, so a bunch of things for you to do this weekend. Keep rolling. Send me questions if you have them. Thanks.